Hello everyone, today in this video we'll be learning about a very basic difference between sn1 and sn2 mechanism. So basically this is something that you'll observe in organic chemistry and most people have really doubt in how to exactly note down the difference between the two. When I studied this mechanism for the first time, even I sort of discovered some problematic issues while learning about the difference between SN1 and SN2 mechanism. So let's see what is exactly the difference. When I talk about SN1 mechanism, so there is one principle, key point that I have to keep in my mind, that is SN1 mechanism. It always relies on the stability of carbocation. Like if you have a compound, so you're first going to see whether it is able to form a stable carbocation or not. That means whether it is able to produce a tertiary carbocation or not. And then if it follows, then it might just go on with the SN1 mechanism. And when I talk about the SN2 mechanism, so that is something which depends upon the steric hindrance. But what is exactly the steric hindrance? Steric hindrance basically refers to the bulkiness. If you have a compound which is extremely bulky, in that case it is not going to be stabilized in accordance with the SN2 mechanism. So when I talk about the SN2 mechanism, so it will rely on the steric hindrance. So if I talk about the order in case of SN2 mechanism, so first it is going to be primary, followed by secondary, and at the end we'll be having the tertiary carbocation. But when I talk about the SN1 mechanism, in that case, first it is going to be tertiary, then it is going to be secondary, and then lastly it is going to be primary. So that's how the order follows. Now in front of me, I have my NCRE textbook. So in this book, a lot of things have been written, but not in a very good manner that you might be able to understand that. Okay, but let's just read it out. Okay, this is something written about the SN2 mechanism. So it basically says that the rate depends upon the concentration of both the reactants. Well, that's also absolutely correct. Because in SN2 mechanism, it not only depends upon the nucleophile which is attacking or replacing your halogen existing in your compound, it is also dependent upon the substrate. Substrate is that alkene on which the nucleophile is attacking. So in SN2 mechanism, it will rely on both the nucleophile as well as your substrate. But in case of your SN1 mechanism, it will not rely on the stability or on the nature of the substrate. It will only depend upon the nature of the nucleophile which is attacking that alkene or whatever compound that you're having. So here also the similar things are written. I'm just going to tell you something different that I haven't just said, I guess. So here you'll see that in SN2 mechanism, it is following a single step and there is no intermediate formation. you know so everything is happening in a single step. That is also a very big difference between SN2 and SN1 mechanism. Okay, you can also understand in this way, like for example, you want an ice cream, and you're in a shop, and you want to have a chocolate flavor ice cream, and that's only one left, and there's another person which is having that last chocolate flavored ice cream. Now with utmost desire you want that ice cream, right? So what you can do, you can definitely steal from that person. That's the only possibility that you have right now. So what you can do is that either you can ask the person politely that, can you give me this ice cream, I'll give you double the money that you got. Or you can do one thing, that without saying anything, you simply grab it up and you just run away. You know, when you choose a second option, that means you're just grabbing it and you're just running away. That will happen in a single step. Okay, you're not making several steps, you're not asking that person, hi, can you please give me, all that drama is not happening. You're simply grabbing the ice cream, you're running away from that place. So you can see only a single step is present. So that will be your SN2 mechanism, because it is taking place in a single step. But when there are different steps involved, that will be your SN1 mechanism. I have already mentioned in the starting of the video that SN1 mechanism, it depends upon the stability of the carbocation. In SN1 mechanism, there is a very, very important step, and that step is the formation of a carbocation. Okay, this is the most important step. And then you will see that the deprotonation of the carbocation will later on occur. But in case of SN2 mechanism, things are very simple. Okay, it will occur in a very the simplest way possible. There's no drama which is happening. you know and also there is one condition about your SN2 mechanism, that over here, there should be a definite arrangement that should be present. I don't think so that I have mentioned about this. Okay, but I'll tell you what's exactly happening. Give me a minute. Actually, in your book, nothing is given. This book is literally the waste. Okay, there's nothing given. So I'll just tell you what I know, and accordingly you can just understand things. See, SN2 mechanism, it also depends upon the orientation which is present between your nucleophile, the substrate, and everything. That orientation really matters in case of your SN2 mechanism. When the attack of nucleophile is taking place, it is compulsory in case of your SN2 mechanism that everything has to be inclined at 180-degree angle. There are two things, the one which is replacing and the other one which is getting replaced. Your nucleophile is going to attack your alkene or whatever compound that you're having, and there will be a halogen atom which will be getting removed. You know, so there is one attacking group and there's a second group which is a leaving group. Remember, in SN2 mechanism, there has to be a specific orientation between the attacking group and the leaving group. That is, both of them should be inclined at 180-degree angle. Remember, this orientation has to be followed. That means both of them should be oppositely present. But in case of your SN1 mechanism, such an orientation is not followed. It's not necessary. You know, so you see, SN1 mechanism is comparatively simpler. I mean, like I know there's a bit drama happening, but still there is no dependency. Okay, it's very independent. So that's what makes it better choice whenever you're going through such reactions. So it's comparatively better. So you see that in case of your SN2 mechanism, there is also inversion of configuration. As I've told you, right, that this is your nucleophile which is going to attack and this is your halogen which is going to leave. And I've already mentioned that both of them should have the difference of 180-degree. That means they should be sort of inverted to each other. Okay, that's some kind of orientation that we can basically observe. So that is very important to understand. That is of utmost necessity. But such an orientation, as I've already told you, is not seen in case of your SN1 mechanism. That's what makes it different. So that's what you need to understand. Okay, this SN1 is not going to look for a specific orientation or such important points are not clearly mentioned in your NCRT. That means it's present in a very indirect manner. So I'm just telling you whatever I know. So you should also understand that whenever these SN1 mechanism occur, they always occur in a sequence. There is a sequence which is taking place, and sometimes there is also a formation of racemic mixture. What is exactly a racemic mixture? In racemic mixture, what can happen is that there can be cancelling out of two compounds. Okay, well, that also depends mainly on the orientation, which leads to cancelling out. So what exactly happens here is that, for example, you have two compounds and both of them are inverted. So obviously, if such an orientation is existing, somewhere they both will cancel each other out. Their effect will be cancelled out. Well, so that will basically form a racemic mixture, which has the same ratio. So this sort of mixture is quite stabilized if you observe it carefully. So you will see that it is very much stabilized. You know, so that's how things basically work. And as we have seen that in SN2, it just will happen, just grab the ice cream and run away. It's like that. It will occur in one step, but in case of your SN1, you have a sequential order that has to be followed. So you have to follow that. So that's how things basically work, and I hope this is very much clear, you know. So that was it. Okay, I've already mentioned about most of the things, and racemic mixture. Okay, don't have anything very important in that. And racemic mixture simply means that there's such an orientation where things are canceling each other out. Okay, so in a racemic mixture, just can you tell me one thing, whether there will be symmetry present or not? Tell me, if you have a racemic mixture in front of you, can you expect it to be symmetrical or asymmetrical? So, well, the answer is that it is going to be symmetrical in nature, obviously. Okay, the orientation is canceling each other. You know, there is a 50 is to 50 ratio obtained. So, there is a great sense of symmetry which is present there. And if there is a great sense of symmetry which is present there, so it simply means that it is going to be symmetrical. But why am I discussing about symmetry out of nowhere? You know, see, it is very much related to another topic, that is optical activity. I will not be discussing about that in a very much detail right now, but I can give you a very small piece of information regarding that. Okay, what makes something optically active? What makes something optically active? When something is unsymmetrical, when there is no symmetry, everything is so distorted, that can make something optically active. But the moment there is a sense of symmetry present, that will make it optically inactive. I have repeated myself several times. How is a racemic mixture? What is the nature of the racemic mixture? It is symmetrical. So, can you expect it to be optically active? Absolutely not. Your racemic mixture is going to be optically inactive. Why? Just give a one line answer. That is, it is symmetrical in nature. That is why. So that's how things basically work. And I think I've already said a lot. Yeah. So let's end the topic. I hope it's clear. Thank you.